We're going to be looking at the sine as a function. This is the second video, and we'll be looking at the cosine and tangent as well this way. And I want to just look at some of the things we've done before, but I'm also going to talk about some new terms, and I'll tell you what those are when we get there. Okay, so we'll come back and look at this. So let's share. Okay, I'm going to start with the graph of the sine that we've seen before. Okay, so the first question I have is here, and let me pose it here. How long is the cycle of the sine function? In other words, how long before it repeats? Okay. And again, you want to look at it here. You notice that like it's just the same thing repeated. Like it looks to me like there's a cycle from here and then one to here. To me, those look like, that looks to me like the length of one cycle. It starts to repeat itself. It starts at 0, goes up to 1, back to 0, down to -1, back to 0, and then it repeats. So to me, the question here is, it looks like it repeats itself. Sorry, again, I want to make this a note. It repeats itself every 2 pi. Okay. Remember that when I make a note, I can't put the pi in there. Okay, that's just called the period. So you would say that the period is 2 pi. The period is the length of one cycle. Okay. Okay, so I'm going to ask you another question. What is the height from the horizontal axis? Again, if you look at it, you can just look at some points. You can see the high point is 1. The low point is -1. So the height is just going to be 1. So the height is 1. Oops. Again, I'm sorry, I keep forgetting to specify that it's a note. I'll just say it here. Height is equal 1, and the height from the horizontal is the amplitude. So the amplitude of sine x equals 1. Okay, and the period of sine x. Okay. Now we can change these by adding numbers. So here's a new one. I'm going to put g of x equals 4 sine of x. Okay. Oops, I know that thinks it's a note. I want to make it a math expression. Okay, so I'm going to see how it's higher now. So the question is how high? I'm going to turn that off. Well, again, you can just look, and the height from the horizontal is 4. So here we would say that the amplitude of 4 times sine x is 4. Now, let's look at another example. We're going to look at minus. Okay, let me take off this one. Okay. Does the height change because it's a minus? No. The height is still going to be 4. So here, and I'll summarize this here, when we get back. So to Zoom, the amplitude of minus 4 sine x is still 4. Okay, it doesn't matter whether this number is minus or negative, you just make it a positive. So again, what this sort of suggests is that the amplitude of f of x equaling a sine theta is going to be a if a is positive, If it's negative, we would say it's absolute value of A. Okay. Or you could just say that the amplitude, since you know the absolute value of something positive stays positive, the amplitude of this right here, of f of x, equaling A sine x. Okay, I forgot the A there. Put it in here. Is going to be absolute value of A. Okay, so we'll come back to that. What's the range here? So let's go back to this one. What is the range of f of x equaling sine, just plain old sine x? So we're going to change our graph, turn this graph off, and down here I'll just put f of x equals sine x. You can see the range is going to be between the height is between the tallest is 1, the smallest is minus 1. So the range is going to be, you can either say this interval minus 1 to 1, or you can say minus 1 less than or equal to x, less than or equal to 1. Either one is fine. Okay, now I'm going to ask a different question. So I'm going to take this off. I'm going to say, well, here. I'm going to change that just a little bit. What is the range of 4 times sine x? Let's see what changes. Again, let's graph it. You can probably figure out what it's going to be. And you can see that the range goes high of 4, low of minus 4. So what the range is going to be is minus 4 to 4. So what we can say is that the range of f of x equaling A times sine x, where A is positive, is going to be, notice how it connects precisely to this. It's going to be minus A to A, or minus A is less than or equal to x, less than or equal to, less than or equal to x, less than or equal to A. Okay. So here, I'm just going to show you, just again to reinforce that, I'm going to just change this to an A, and we have a slider. And notice that as A changes, so does the amplitude, so does the range. So the key is going to be that the range is really closely tied to the amplitude. Okay, so I'm going to go back and stop the share and sort of say what we've decided so far. Okay. Sorry, couldn't just find the, here we are. Okay, so we saw that the range was going to be, of this function here, was minus 1 to 1. The amplitude, we haven't talked about the period, was 1. And in general, we saw that if f of x is equal to A sine x, that the range is going to be equal to minus A. Here, I'm just going to, again, assume A is greater than 0, keep things simple. And then the amplitude is going to be equal to the absolute A, which is going to be A since A is positive. Okay. Now I want to look at the period. Okay. And the period is going to be how long does it take before it repeats itself. So let's go back and look more closely at that. So we're going to share again, and this will be the last thing that we do. Oops, sorry, I didn't mean to share to the whiteboard. That's just so automatic to me. That was a mistake. Let's share to Desmos again. Okay. And I'm going to take off all these things for Desmos because we don't need these anymore. Okay, so we're going to look at the graph. F of x equals sine x, and the period is equal how long a cycle is equal how long it takes to repeat. Okay, so I'm just going to take this off for a second. We'll come back to it. So when does the graph repeat itself? Well, if we start here, 0, 0, we go over here, go up to minus, go up to 1, back to 0, minus 1. It starts to repeat here. It looks to repeat 2 pi. One trip around the circle, right? So we saw that before. So that's just a reflection of that. That once we get beyond 360, it starts to repeat itself. And if we go in the opposite direction, start at 0, let's go backwards. Let's go minus 1, 0, up. It starts to repeat itself in both directions. So it repeats itself every 360 or 2 pi. So I'm going to say that for the sine, for f of x equals sine of x, the period is 2 pi. And again, you might think of it as 360 degrees. And again, that's where the angles start to repeat themselves. Okay. So, well, let's do what we did before. Let's look at f of x equals sine of 2x. And let's take this off because that's going to be a mess. How long does it take to repeat itself? So let's just trace it. Minus 1, 1, back to 0 again. If that's one full cycle, it's pi. Notice things happen twice as fast. So we go through the angles twice as fast. So again here, the period is going to be not 2 pi, but pi. And one way to think about this is that 2x is going to be equal to 2 pi. Here, let me put this, because, spell right, 2x equals 2 pi implies x equals pi. We go through things quicker, the period is shorter, 180 degrees. Then things start to repeat themselves. Okay, again, let's look at another one. F of x equals sine of minus 2x. Turn this one off. Same thing, the graph flips, but it still repeats itself every 2 pi. I'm sorry, every pi, every 180 degrees. So I'm just going to mention this, 180 degrees. Okay. So again, the period is still 2. Okay. So let's do a couple more. I think you know what's going to happen. F of x equals sine 3x. Turn this one off. Let's see how much it takes. Start to 0, you go to here, every 2/3 pi. So again, I'm going to write a note. If we go through this, again, we go one full cycle and we see that we're at 2/3 pi. So again, the period of sine of 3x equals 2/3 pi. And again, if you wanted to figure this out, because you would solve 3x equals 2 pi, that's when the angles repeat. That would tell you that x is equal to 2 pi over 3. So again, that's what the period is. So I think you can figure this out. You know that if we look at, again, I want to make sure this is a note. The period of f of x equaling sine ax equals is 2 pi, 2 times pi over whatever our a is. Again, let's assume a is positive. So we'll make it an absolute value to make it positive. Okay. And that's because if you solve, I'm sorry, I'm going to use a B here because we used A for amplitude before. And that would be because when you solve bx equaling 2 pi That's going to give us, we divide each sides by b, that's going to give us 2 times pi over b. And again, here we're assuming b is greater than 0. If b is less than 0, then the period is going to be the absolute value. So just make b positive. Okay, now I'm going to summarize this on paper, and that'll be the last thing that we do. Okay, so again, you can always, if you want to find the period, you can just always look at the graph and see where it starts to repeat. And the same for the amplitude. You can see its height by just plugging it in. Okay, so we'll do some practice problems later. I'm going to stop the share and go back and summarize. Oh, I didn't look at the domain, but we'll do that. Okay, so the period is length of one cycle, so the period of f of x equals sine bx is 2 pi over the absolute value of b. Okay. Okay, and then the domain, we didn't go over this, but it's going to be all real numbers. If you look at the graph, it just keeps going in either direction, and that's because any real number can be seen as an angle. We talked about that before and what the domain was. Okay, so that's going to be it for the sine, and see you in the next video.